Hello and welcome to AT&T Cabling Systems Technology Presentation Series. In this presentation, we are going to talk about healthcare technology. We are going to talk about TIA 1179, which is healthcare standard, as well as we are going to talk about Cat6A and Cat8 cabling systems used in healthcare facilities. My name is Taif Shakir. I am Technical Manager for AT&T Cabling Systems handling Middle East and North Africa. Healthcare facilities leading the IT technologies because they are using highly sensitive medical equipment in an environment saturated with electromagnetic interference. Most of those equipment must be able to send and receive high-speed data, and it must be immune to disturbance and hacking, as the life and privacy of patients is very important. This presentation deals with cabling systems in healthcare facilities, and it explains the roles and minimize the effect of electromagnetic interference by enabling high-speed, safe, and error-free communication. Designers nowadays looking for optimizing the connectivity of the hospital. It can be done by faster first response, next generation IT, flexible bandwidths, reliable access, seamless communication, mobile electronic health records, and equipment monitoring. We are going to discuss the top 7 digital healthcare trends in 2020. As the latest digital trends continue to shape healthcare, organizations should keep few key considerations in mind. For healthcare organizations, whether big or small, 2020 marks another step toward more innovative patient and provider experience. There are new concepts like Internet of Medical Things, large-scale data initiative, telemedicine, and more. We are going to discuss 7 digital trends that are going to shape healthcare in coming years. The top 7 digital healthcare trends in 2020, starting at IoMT, which is the Internet of Medical Things. This includes patient wearables, automated kiosk, virtual assistants, and more. The Internet of Medical Things trend is in full swing, but effectively implementing in 2020. It means having much deeper understanding for organizational and patient needs. According to Frost and Sullivan, they are predicting number of Internet of Medical Things devices to be 20 to 30 billion by 2020, which means healthcare organizations will have greater accessibility but also greater number of choices. There are few questions that we need to keep in our mind in order to do best design. What are the specific needs of your organization or your patients? What combination of Internet of Medical Things devices that have the biggest impact? What technology partners can help implement these technologies most effectively? The second healthcare trend is digital initiatives. Despite the widespread desire for data utilization, we are only just starting to understand what collecting it really works like. According to new industry research from HIMSS Media and AT&T, 43% of hospitals are engaging in big data initiative this year. And with that comes a handful of challenges to consider. The biggest is the data quality. Most data collectors require thorough cleaning and sorting in order to be referenced and shared out, which in turn requires additional process to be put into place. Other watch outs include physician burnout from manual data entry and lack of privacy system for collected data. Artificial intelligence is one of the top subjects that will be in the future of healthcare. There are estimations for artificial intelligence markets that will reach 6.6 billion by 2021. One crucial thing to remember when considering artificial intelligence for the organization, studies shows the healthcare industry itself is the fourth lowest in terms of job automation potential. Human-centered healthcare jobs are not at risk because at the end of the day, patients still crave human-to-human interaction when it comes to their care. According to Stanford Medicine, one of the biggest benefits of artificial intelligence is the potential for healthcare organizations to analyze mass amount of data. Telemedicine is another trend in the future for healthcare sector. Studies saying that younger patients looking for more digitally savvy care. The demand for tech-facilitated options decrease cost and it is convenience, and the personalization is driving both innovation and adaptation. Augmented and virtual reality, it is one of the top digital healthcare trends in the future. Imagine there is a medical student who is trained for a complex surgery using augmented reality, or a distressed patient is instantly transported to a sunny beach. The healthcare market is getting close to adopt practices just like these, but many of the technologies needed to implement them are still emerging. Cybersecurity is one of the most important subjects that we need to discuss in healthcare. In the first 2 quarters of 2019, there were 286 publicly disclosed data breaches and over 32 million patients records for the entire 2019. This is cited by Proteus Breach Barometer. Therefore, 2020 might just prove to be the year of increased cybersecurity measures. While healthcare breach costs among the highest across industries, choosing the right managed security solution provider, MSP, to help defend against them is crucial to maintain the patient trust. Without patient trust, very little can be achieved. The last digital healthcare trend in the future is the 5G technology. All the other trends that we talk about can rely on 5G to enable successful implementation, such as telemedicine, AR, VR, IoT, and more. For integrated healthcare networks like Rush Health, 5G means better hospital operations, as well as improved patient and staff experience. But adopting such a large-scale technology comes with its own set of challenges. That's why it is essential to involve both medical and technical expertise when considering 5G for your organization to ensure the patient's experience remains at the top. High-speed data can be supported by several different technologies, but the most economical cabling solution providing the best benefit to cost ratio is Category 8 copper cabling system, which is supporting 40 gigabit per second up to 30 meter. After finishing the healthcare trends in the future, we are going to talk about healthcare IT infrastructure. In order to support all healthcare communications needs, a robust IT system is needed, which in turn requires an adequate cabling infrastructure. It is highly recommended following TIA standard 1179-A, which is published in September 2017. This standard provides specifications for planning and installation of structured cabling system for healthcare facilities. It includes requirements for cabling, cabling topologies, cabling distances, pathways and spaces, and other ancillary requirements. Guidelines on selection of media and network designs is provided for larger healthcare facilities, which may have a useful life for larger and traditional office-oriented commercial buildings. ANSI TIA 1179-A significant change from the older version is a minimum category required is Cat6A cabling, and it's specified for the use in horizontal and backbone cabling system. A minimum 850 nanometer laser optimized 50/125 micrometer or M3 is recommended for use in the horizontal and backbone cabling system. Multi-mode and single-mode optical fiber cabling shall be support at least 2 fibers. Array connectors or MPO/MTP connectors are now permitted for optical fiber cabling in the work area. Additional requirement for pathways and spaces, bonding and grounding, fire stopping, support for broadband coaxial cables, and multi-tenant building spaces have been added. Additional recommendation for wireless access point and distributed antenna system have been added as well. So this is very important standard to study and to implement during network design. Additional ANSI TIA 1179-A highlights. In this standard, it's ensured the work area outlet distances reflected the need for each specific work area. And the work area distributed in multiple classification, mainly 3 types. L, which is low, it has 2 or 6 outlets in each area. M, which is medium, it has 6 to 14 outlets in each area. And H, which is high, it has more than 14 outlets in each area. And the work area specification according to the area that it is serving. For example, patient services, surgery, emergency, women's health, each one of those having different density classification. Based on recent research that there is more than 60% of hospitals have category 5E and Cat6 cabling system installed. This will limiting their ability to support future technologies. Only 40% of the healthcare facilities feel they are providing enough wireless connectivity in high density areas. 65% of healthcare facilities are investing in wireless infrastructure upgrades. 46% of healthcare facilities are implementing cabling upgrades. So it's critically important to ensure all the presence of future cabling upgrade in healthcare facilities will support the fastest application, both in wired and wireless. The following slides provide AT&T Cabling System recommendation and guidelines. LAN cabling basics. LAN cabling is defined by categories, which are defined by a set of transmission parameters specified in certain frequency range. It is possible to replace the connectors and patch cords, but replacing horizontal cable is expensive, difficult, and in many cases impossible. LAN cabling systems should have a useful life of 10 to 15 years. The cost of horizontal cables is negligible compared to the cost of installation. For all of those reasons, it is critically important to select the best cable available at the time of installation. Most users understand this, but many of them are not sure what is the best cable they have to use. So we are here to help. Following the guidelines of ANSI TIA 1179-A, the lowest category selected must be Cat 6A. But Cat 6A comes with large variety of construction. This will include UUTP or unshielded, FUTP, UFTP or FFTP, and even SFTP. Installing unshielded system or cabling system in any healthcare facility may be a fatal mistake, especially for the patients. So it must be avoided as much as possible. Shielded cable must be properly the best choice, and it has to be grounded. Cable selection for healthcare facilities. Modern healthcare facilities include sophisticated equipment, which is vulnerable both to electromagnetic interference and hacking. Extensive research has been done indicating the vulnerability of medical equipment to cellular phones and several other sources of electromagnetic radiation. Those sources are including pagers, cordless phone, tablets, portable radio transceivers, tracking devices, laptop computers, telecommunication antennas, and even radiation generated by systems used by hospital itself. It should be noted that affecting frequency range from 125 kHz up to 2.5 GHz. And many malfunctions were life-threatening. Most of these papers conclude what should be the minimum distance between the equipment and the electromagnetic interference source. This is ranging between 4 cm and 6 meters. Unfortunately, none of those papers checked what is the effect of the cabling system on the equipment or on the hospital equipment. All modern healthcare equipment is connected to an IT system, so it can be controlled and monitored from a distance. This connection is done by LAN cables, even when the instruments are connected to a wireless system, which is rare in hospitals. At the bottom line, cabling system in healthcare facilities must be shielded, and the only point open to discussion is what type of shield is needed, or in professional terms, what is the coupling attenuation and the transfer impedance of those shielded cables. Now, what type of shielded Cat 6A cable is suitable for healthcare facility? We need to know that the efficiency of shield depends on the shield construction and the DC resistance of the shield to the ground. The term DC resistance is used for simplicity, although the ground path impedance, or ZG, is the actual parameter at high frequency transmission. The values are not the same, but lower DC resistance create lower ZG, or lower ground path impedance. We can see in front of us three types of shielded system or shielded cables. SFTP, the overall copper braid grounds the currents created by electromagnetic interference in the aluminum foil. This is 360-degree contact range. It is manageable coverage and resistance. While UFTP and FFTP cables, a single copper drain wire, serve as a main path to the ground. One point of contact, high resistance, usually it is 24 to 26 AWG wire of drain cable or drain wire. While UMTP cables, there are no ground at all, so the shield efficiency is zero, or in other words, the cabling is effectively unshielded cable. SFTP cables recommended for all large projects, including hospitals. The copper braid adds to the cable costs, but it provides the most efficient shield. High coverage braid, usually more than 50%, provide high coupling attenuation. This means high protection against strong electromagnetic interference. It's improved the low frequency shielding, or ZT, the pair's balance, and the cable ability to survive abuse during installation and handling by holding the foils tightly wrapped around the pairs. The high metal contents also improve the heat dissipation, and this is very useful when you are using PoE application. In order to ensure the level of electromagnetic interference or electromagnetic compatibility, the cable must be specified and ETL verified according to the highest limits specified in IEC 61156-5. Coupling attenuation, CA, it is type 1, 85 dB minimum at 30 to 100 MHz. Transfer impedance, ZT, it should be grade 1. Testing is expensive and time consuming, but it must be done in order to minimize the risk to the patients. Now the selection is SFUTP or SFTP. Several vendors offer overall shielding Cat6a cables such as FUTP, SFUTP. This construction is indeed efficient against alien crosstalk and electromagnetic interference, but it has adverse effect on the other parameters. Let us discuss it. It reduces the near-end crosstalk and the far-end crosstalk losses between pairs inside the same cable. In high-quality SFTP cables, the individual foils surrounding each pair provide outstanding near-end crosstalk and far-end crosstalk losses. It reduces the balance of pairs due to uneven distance to the foil, and in this statement we are talking about the SFUTP cables. In high-quality SFTP cables, the individual foil maintain the shape of the transmission line in a perfect condition during production, packing, and installation of the cable, ensuring a very high and stable balance cable. So it is evident that the best way to minimize the impact of electromagnetic interference on healthcare equipment is to install properly shielded cables having SFTP construction, and this opens another discussion. Why install only Cat6a cable when there is a brand new high cabling category, namely Cat8 cables? We are going to discuss it in next slides. In many large scale and sensitive cabling projects, The horizontal cabling selected are designed as SFTP, as we said, usually having Cat6a. Even designers go for Cat7 or Cat7a transmission properties. In 99% of these projects, the connecting hardware transmission properties are category 6A or even lower, and the channel are tested as category 6 or category 6A. This is done because of the following reason. Category 7 or category 7A connecting hardware is much more expensive than category 6A, and it is more difficult to terminate those connection hardware to the cable properly. All active equipment, and this is one of the most important points, all active equipment has RJ45 category 6A or lower outlets. This will reduce any Cat7 or Cat7A channels back to Cat6A or even lower category. Until recently, the fastest protocol was 10 gigabit per second or 10G base T, which runs perfectly on Cat6A cabling. In other words, there were no IEEE X base T protocol that needed Cat7 or Cat7A cabling system. So why are Cat7 and Cat7A cables or even IEC 61156-7 1200 MHz cable installed at all? Why should anyone spend money on cables which are not needed? Cat7 and Cat7A cables were installed because of the following reasons. Designers think about something called future proofing. The horizontal cables is difficult and expensive to replace. Of course, it's compared to the connecting hardware. So many consultants and designers recommend to use the best cable available at the time of the design. They will hope it will not have to be replaced when faster protocols are invented. Another point is the quality of service. Using horizontal cable, which is a higher category than the connecting hardware, is a way to ensure the channel will provide better support for protocol. This will minimize the bit error rate and maintain as high data rate as possible, as the horizontal cable having substantial headroom over the related category limits. This will cause minimum degradation to the transmission properties for the channel, even if it's abused during installation. Those were the 2 points designers rely on when they are selecting higher category cable with lower category connectors. But above policy was found partially justified. The quality of service is indeed better. All channels made with Cat7 and Cat7A cables, as well as Cat6A cables, will be able to support the new 2.5G base T and 5G base T protocols, or what is known as N base T, according to IEEE standard A02.3BZ that ratified in 2016. But most of Category 7 and Cat7A cables will not be able to support the latest protocol, which is 25/40G base T. This statement is based on a formal decision taken by IEEE P802.3BQ task force. This task force rejecting a specific demand of ISO IEC JTC SC25WG3 to enable the use of Cat7A cable in support of 25G base T, while 40G base T was not even discussed. As indicated, ISO have an attempt to qualify some short channels to support 25G base T on installed cables. So after all the talk about Cat7 at Cat7a, and they are not supporting the new 25 and 40 gigabit per second, we recommend to use Cat8 cables for those reasons. It has an exact same construction of all other SFTP cables, making the installation identical to Cat7 at Cat7a cables. It has bandwidth of 1 to 2000 MHz, which is the highest bandwidth available in the market today. It is based on fully ratified and published standard, which is TIA 568.2-D and IEC 61156-9. It is ETL verified. It is designed to support IEEE 25/40G base T up to 40 gigabit per second on 30-meter channels and all other existing protocols on 100-meter channel. Note, based on the fast advancement in chipset technology, it is reasonable to assume that within a few years, a 100-meter 40 gigabit per second protocol will be available. This will enable the use of more than 30 meter in one channel. Actually, the extra cost involved using Cat8 cables, SFTP cables, instead of Cat7 and Cat7a or even 1200 MHz cable is negligible when we are calculating the total cost of the entire cabling system. When the total costs are calculated based on the number of usable years of the system, the cost of ownership per year is substantially lower when AT&T cabling system Cat8 cable are used. In addition to the cable, AT&T cabling system can provide a channel level Cat8 jacks and cords. RJ45 jacks complying with Cat8 limits at the component level are not available yet. So, in the meantime, users have the option to use our Force or Delta EEC verified channel level Cat8 jacks and cords. Those jacks support channels made with 5 meter permanent link with 1 meter cords and 24 meter permanent link with 2 meter cords. The pros: availability to run 25 gigabit per second and 40 gigabit per second. Now, it is backward compatible to AT&T Cat6a and Cat6 component systems. The cons are the interoperability with Cat8 cords from other brands cannot be guaranteed. To sum up, modern healthcare facilities must have a robust IT infrastructure that can handle the high-speed data rates needed without being affected by any of the many electromagnetic interference sources and without affecting the delicate medical instrument. Therefore, it must have a perfect electromagnetic compatibility. Poorly shielded or even unshielded LAN cables with low balance will emit high frequency radiation and are easily affected by electromagnetic interference. So, cables used in healthcare facility must be SFTP. The lowest category recommended by ANSI TIA 1179-A is Cat6a. This will support IEEE 10G base T or 10 gigabit per second application. Installing Cat8 cable instead of Cat6a will provide future proofing. This will enable the support of the fastest protocols available today, mainly the 25 and 40 gigabit per second, at a similar cost and identical installation method of the normal Cat6a cable. Thank you very much for attending this presentation, and we are looking forward to have you in our future presentations. Take care.